Okay, this is a little bit more of target 5, the law of sines with the ambiguous case. This means that anytime you initially have two sides and an angle when you're working with the law of sines, you could run into weird situations. So we're going to spend a few minutes talking about what those situations look like and how to deal with them. Again, when you have two sides, like sides A and B, and the angle across from one of them is angle A. All right, so here's a situation like that. Set up the law of sines and solve for angle B. So I'm going to use angle B inside B. I guess I really want to solve for angle A, not angle B. So use angle B inside B and say that 10 divided by sine of 150 degrees is equal to 64 over sine of angle A. So after cross multiplying and working that out, this equation is going to lead to 64 times the sine of 150 degrees divided by 10, and that will equal sine A. So 64 sine 150 divided by 10. 64 times the sine of 150. Make sure I close my parentheses. Divide by 10. I'm going to get 3.2. So sine A is equal to 3.2. And once we have the sine ratio, we need to take the inverse of 3.2, sine inverse of 3.2, to find angle A. If you need help back with this step of like what happened on that mysterious arrow, if you need help figuring that out, you can go back and look at the target 5 law of sines video where I work out with the cross multiplying, solving that proportion. So anyway, inverse sine of 3.2, we type that in, second sine, inverse sine 3.2, we get a domain error. So that's a domain error, not a syntax error, which means that there is actually an issue with our problem. Okay, so this gives me an error, or specifically a domain error. And what that tells me for this problem is that this triangle does not actually exist. There is no angle that exists where if I take the sine of that angle, I get 3.2. What are things we could notice that will tell us this is going to happen? The first one is that the side opposite this largest angle was too small. If I go back up and I look at what's circled, the 150 degrees has to be the largest angle in the triangle because it's obtuse. So there can only be one obtuse angle in the triangle. The side 10 is clearly smaller than the other side 64. And one of the things we know about triangles is that the largest side has to be across from the largest angle. So that's already information that tells me there's something wrong with this information. A second way that I could tell is that the sine value is too big. We tried to do the inverse sine of 3.2, and what I typed up there is that the inverse sine, or the sine value, is greater than 1. That's too big. The sine value can't be greater than 1. If we look at our right triangle, we know that the sine of A is equal to the opposite side over the hypotenuse. Well, the hypotenuse is the largest side in a triangle by definition for a right triangle. So this value will always be less than 1 when we're looking at a right triangle. The sine of an acute angle A will always be less than 1 because the opposite side divided by the hypotenuse, the opposite side is a smaller number divided by a larger number. And so that's always going to be less than 1. So that was an example of what happens sometimes with the ambiguous case when there's no triangle that exists. I'm going to make a separate video for two triangles.